Hello. Hello. Hey guys, am I audible? Cool. All right, we'll hang out there for the next 10 minutes. Maybe 5 to 7 minutes till 6, 7. Because there are a lot of other guys who are coming in.
Yes. Hi, Sunil.
Hey, hi Gwen.
So 30, about 36 students now. Oh, we have to admit every student, right? They join.
I think they are all admitted. There's no one in the waiting room now. If I see any, I do add them. So I have a parallel windows running, one on the desktop and one on my MacBook. We'll wait for the next 5 minutes for people to get in. Yeah.
Hi, Sunil. Did you see the email from Jamie? Can you hear me, Sunil?
Hi, Gwen. Yeah, I can hear you.
Did you see that email sent from Jamie? Jamie Clark.
This one, right?
Yeah. So probably we'll still talk about that later. Yeah, we'll talk about it.
Cool. No worries. We'll talk about it later. Yeah. So, hi everyone, I'm Sunil, and with me here is Guan. Uh, Welcome to FIT 5042 Enterprise Application Development for Web. This is semester 2 2020. So, Guan is the chief examiner, and if you need any extensions or medical leave or anything, you just have to connect to Gwen. He's the co-lecturer as well. So I'm the evening lecturer. I'm Sunil Panda. I'll be running the classes for Tuesday 6 to 8. I have my lab Monday the same time, 6 to 8 evening. So bit about this unit. This unit is for developing enterprise web applications. A brief history about how different architectures have evolved to give rise to enterprise web applications. This unit is a little hard. This is difficult. All right. So if you have a good understanding about how to program, or you have understanding about Java, then I feel it's a good unit to learn a lot of advanced topics in industry that can range from uh, Java frameworks, different tools used around Java, uh, JSF, JSP, EJBs, architectures, Spring MVC, Spring Boot, containerization, and Docker, and deployment to cloud likewise. It is really advanced when it goes on from week 1 to week 2 to week 3. The complexity and the dedication required from you to have that understanding is going to expand exponentially. So you need to stay focused. Simply be very dedicated and diligent to this unit. And a little about myself. I'm Sunil Panda, as I just said before, previous 2 minutes back. I'm Sunil Panda. I'm the lecturer for this unit. I work at Monash part-time. My full-time work is in NAP. I used to work with Accenture, Infosys, and yeah, and did the small projects here and there with other consulting firms. Basically, my area is currently in architecture is another thing, but yeah, my whole background has been development and around webs, and I have seen how things have changed from one part, one architecture evolving into another architecture, and the technologies in today's world are definitely changing. And at present, the rate of change is very high. So you got to um, take a seat, grab yourself, and stay focused. You will be learning Java and some of the JavaScripting framework like AngularJS as well. So everything will be hands-on. We have very skilled teaching team. Some of them like Elliot, who is a tutor. he has contributed a lot in development of this course. There is another ex-tutor. His name was Varun. Some of the credit goes to him for development of this content for this advanced material for this lecture. And of course, to the whole team for collaborating and development for this unit. Before we start, I'll hand over to Guan to give a introduction about a brief about himself. Guan.
All right. Thank you for Sonio. Um, Firstly, I want to say hello everyone. Welcome to this unit, FabLio42, Enterprise Application Development for the Web. Okay, just briefly about me. My name is Guan Xiaoxiang, and my email address, so I just put into the chat box. And if you have some important issues, concerns about this unit, you can email me, right? And basically, I completed my PhD in computer science from Monash Uni in 1998, which is a long time ago. Right? And before and after that, I worked as a software engineer or a senior software engineer in the IT industry in Australia for many years, mainly in the web development. And I started teaching for IT in Monash since 2016. So I've been tutoring and teaching here for Faculty of IT for more than 5 years. So and this is my fourth time to teach this unit. So I hope you enjoy the course. This is very briefly about me. Now, Sunil Panda is the lecturer of this unit, and Sunil will be the lecturer who make the the speech each time. Okay, and Sunil has been lecturing and teaching this unit for the last few years, so he's a very experienced lecturer for this unit. And during the lecture, so I'll be here, trying to answer your questions if you have any. Before you start learning this unit, I encourage you to carefully read the unit handbook on Moodle, so that you understand the picture of this unit. And such as the workload requirements, and the learning outcomes, assessment requirements, and recommended resources, etc., etc. And so another point I want to make, here is about the sending email. Okay, you probably will be frequently sending email to this tutor, that tutor, or this staff, or that staff, right? But if you want to email your tutor or lecturer or myself, right? So in your email subject, you should mention, FIT FabLio42, mention this very clearly, and which lab you're from, etc. All right. So in that case, so if you don't mention these things, the teaching staff may not know, okay, which unit you are from, right? And which class you're from, etc., etc. So, and he or she will spend time to find all these details. Yeah, and again, welcome to this unit, and hope you enjoy it. Okay, that's all from me for the time being. Thank you. Over to Sunil.
Thanks, Gwen. So I just asked this question before for everyone. Which of the following is a enterprise software system? Payroll system, and database, Facebook app, a mobile phone game, or organizational website? What do you think? You can put it in the chat. Should be okay. Some of the responses that I'm seeing, it's payroll system. You are correct. And why you think payroll system is enterprise software system? Right, cool. Uh, we'll study why it is. I'll answer you at the end of the class, or maybe in between while running through the slides. So for your information, this lecture is recorded. So if whatever you're seeing or anything, you don't have to make personal notes or something. But some of the notes that I will be sharing, you might, you might use them uh, or keep them, such as the one that I'm sharing right now. I think everyone will be shared in their chat uh, the specific links. I've shared you guys these links. All right. Uh, your respective lab tutors will help you in setting up your environment and other thing. At the end of the lecture, if I have time, I'll probably show you how to run through or do week one. All right. Week one lab. Cool. So this is your Moodle. In the Moodle, I'm aware that you know how to join to Zoom through class streaming. And the version for the IDE that you need for the first 4-5 weeks, you need to download from here or from the links that I shared with you just earlier. All right. Um, so this is your lecture slides. You can open them. I have it already opened. All right. So welcome. Uh, in this week, we'll go through sequentially. Yes. So one of your friend has asked me a question if we are allowed to ask questions during the lecture. Yes. You simply unmute yourself and say, "Hey Sunil, I have a question," and then I'll allow you to speak. So make it interactive. We understand that running meeting through Zoom is a bit technically odd when we don't see each other face to face. So if you have any questions or anything, you can simply unmute yourself and say, "Hey, I want to ask a question." Very simple as that. So this unit is focused both on front end uh, coding business logic and creating a bit of databases. All right. So this unit is not entirely focused on the back end, creating schemas, databases, and all. This unit is more to like creating web applications, the front end and the middleware where the front end interacts with, that's in the server, and how it is linked to the end system database systems. So yes, you will also learn some scripting framework, which is Angular. Okay, let me run through the slides before I answer each of your questions from the chat. Um, so we will run through what is unit about and the administration, different aspects of assessment in this specific unit, and overview architecture of enterprise applications. Hey, Gwen, would you do me a favor to keep an eye on the
Yeah, sure. Yeah,
waiting participants and letting them in?
yeah.
Thank you. So we'll also tell you how to provide feedback, and this feedback is about the projects, the weekly tasks that you do in your lab. Your lab tutor will provide you some exhaustive explanation of what is an e-folio is, how to set up in your Google Drive, how to share it with your tutor, what content goes in there, how to set up your GitHub, how to set up your GitLab, and likewise. Look, this unit will not teach you how to do GitHub, how to work with Git or GitLab or Bitbucket, any of the source control system. It's just in 1 hour stuff, guys. I I bet if you don't know how to work with Git or any source control system, you cannot simply go to industry and say that I know coding. If you know coding, you should also know how to source control it. All right. So learn GitHub. So we'll talk about it and how to submit screenshots of your working program along with the links from the GitHub. I'll give you a simple example here, or maybe when we go down the line, I'll show it to you. And some concepts related to enterprise architecture and Java EE. EE stands for Enterprise Edition Application Architecture. So this is the teaching staff. We just had an introduction about it. Consultation will start from week 3 onwards. However, I will discuss with Guan because there has been a lot of requests for consultations right from the week 1. I understand the complexity of setting up environment and everything. So probably I will get back to you based on my meetings outcome. Right, so I cannot do an icebreaker sitting from home. We just did in the beginning with the question, what is an enterprise system? Right, cool. So that was my icebreaker. We'll have some questions coming in between. So prerequisite for this unit, look, as I said you before, this unit is relatively difficult when compared to other units. You have to give 100% of your focus and due diligence. You should be having some experience with programming as well as understanding Java in order to pursue this unit, all right? If you don't understand what's an object is, what's an interface is, you'll have to quickly recollect those oops concept before starting with this, otherwise you may end up with some oops. All right, so classes is a definition of a real world thing, and objects is the representation of the classes in memory is object. Methods, they are the functions defined in a class. Data collections, uh, anything that is a list or a set or a map, they're all collections. That these are different data types. And then interfaces. Interfaces are the definitions, not definition, declarations. They are the interfaces contain method declarations, and the classes which implements interfaces, they generally contain method definition. So there is a difference between declaration and definition of a method. Interfaces just contain one line declarations, and different control structures. Can somebody give me an example of a control structure? Uh, some repetitive structures are like for loop, while loop. Uh, some conditional is like if, else, and sequential are like switch. Good, very good. Good, Harsa. So likewise, so learning outcome. Um, I hope everybody has gone through the unit guide before enrolling to this unit. Students should be able to analyze um, and understand software architecture, enterprise architecture on the web. They should be able to design, construct, and publish enterprise applications using Java. Or because I'll tell you a very frank stuff, guys. If you go to market and say, I know Java, uh, the prospect of getting or landing in a job is very low. But if you tell, okay, I know the frameworks related to Java is this and this and this. The presentation side is JSF, JSP, and likewise. On I know MVC frameworks like Spring, um, Faces. I also know Spring Boot. So Java itself is very, very is just a core. There are a lot of ancillary technologies and framework that uses Java. Just like in Android, it uses Java, but if you say you know Java, you actually don't know what's whole Android is. So Java itself is pretty a bit of core thing, but then there are frameworks around Java which makes it really huge. So you should be able to, uh, you know, uh, able to construct different web applications using the framework that you'll be learning in this unit. You should be able to apply, analyze uh, different Java libraries and frameworks to build a web application in this enterprise, for the enterprise. So because Java, a lot of things in Java is open source, that means a lot of things that you need to do, they are pre-done by developers, and they're available to you as in libraries. So you don't have to do that. Framework is just a collection of libraries. So you just have to use that framework or a library to build advanced stuff. All right, cool. So this is the unit roadmap for the next 12 weeks. The reason why I'm spending bit of time in explaining all these things is because this will create the context in which you will be following for the next 12 weeks. So this is week one. Week one, you'll understand about the enterprise architecture, which is core to understanding Java EE. And next week, you'll learn about JSF framework. It is one of the MVC framework. And then Java Beans in week three. That's where you will learn about how to uh, make business logic. In week four, you'll understand about Java persistence. So any web application, um, you need to have any persistence. You want to preserve the state. That means you need persistence. That means you need a database. So database will kick in in week 4. And in week 5, you learn very interesting stuff, how to secure your web applications and web services. So yeah, so this will web services is the new architecture to build enterprise applications. And based on it, we'll go into week 6, where you'll be developing an SPA, a single page application using Angular 7 or 8. I think it's 7 or 8. I think it's 7. Yeah. So based on, so a lot of web front end work has been done on some scripting frameworks. And these scripting frameworks are nowadays so complex and advanced. Basically, you can create a whole web app using a framework. You don't need to have a JSF or Spring to do. You just need to have a React in the front end and a MongoDB in the back end, and that's it. You can have an Angular in the front end and some Postgres in the back end, and you have an app. So these frameworks have evolved into very mature level. Uh, so we have dedicated one full week into Angular. Um, you'll be learning about the basic of CRUD operations, basically interacting with Angular, how to do create, read, update, or delete data, and bit of web services and UI testing. When I say UI testing, it's basically testing of the web services. In week 7, we'll start with Spring Framework and Spring MVC. And in week 8, we will use Spring MVC. So till week 5, uh, till week 5, we'll be using Eclipse. Eclipse as in for the IDE and Glassface as the web server. As in when we go to week 6, the Angular, we will use Ideas WebStorm. I don't know how many of you have heard about it. The IDE is called WebStorm. So it is an expensive licensed IDE, but it's available free of cost for Monash students. From week 7 onwards, we'll be using IntelliJ. And week 9, where we'll start with some start with Spring Boot, building web services, and using Docker to containerize it. Week 10 would be a little advanced part of it, having running multiple services with Boot, Spring services, as well as MySQL, and building a container and putting it to an ECR, Elastic Container Registry. And then in week 11, we'll deploy it into Amazon ECS, which is Elastic Cluster Service. So, so these last 2 weeks will be a little complex. And what is expected out of you in this area is to uh, just to go at home and try it out at home. All right, so the steps and videos will be provided to you, and an explanation will be provided to you. You can go and try this hands-on at home. We'll not be examining you in week 11th part. For week 11 there will be no examination. However, uh, if you are targeting for people in final semester, you are targeting to get into industry, week 11 is going to be a big booster for your knowledge. It will expose you to one of the popular cloud provider, AWS, and how to work with it. In week 12, we have unit revisions and maybe some more tasks will reveal. Um, if you see on the right column, there is something called as assessment. Look, in week one, we don't have any assessments, but to be honest, practically by week 5, you'll be able to build. By week 5, you will be able to build end-to-end a front-end client using JSF and connecting it through business logic in between EJBs and web server at the end to the database server at the end. So by week 5, you'll be actually be able to create full apps embedded with security features. Now, why I'm saying is that that's one framework is completed. JSF EJB gets completed by week 5. So practically by week 5, you should be able to start building your own apps. And if you see on the right hand side, it says the first draft design report and application code for feedback. So you'll be provided with an assignment. We will talk about shortly how marks are breakdown, how marks is distributed among assignments and assessment at the end. But your part 1 assessment is based on the coursework practical, and that practical consists of design and code, research report. So you need to start with the first draft of design that you will submit by week 5. All right. By week 7, you will have your design improved based on the feedback. And by week 9, you should be having applications running. All right. So you should be having design and code ready by week 9. And then you can keep on adding features in week 10, 11, and week 12, you will have your final submissions. So final submission of your practical assignment will include not just the code, but also design and research report. All right. So there's a lot of hard work going out there, guys. You'll have to be really focused and give a lot of time to this unit. Uh, maybe maybe just if you just give 2 hours of lectures and 2 hours of tutorial, it is just the tip of the iceberg. This is an individual assignment and individual assessment at the end. All right, so the examination after the SWOT week will be e-exam. All right.
Sunil, I have a question. Sorry.
Yeah, go ahead, Tarun.
The project that we are going to work in our tutorials and the assignments that we are going to submit, just to make it sure that they are the same one, right?
No.
Okay.
So, oh, that's a very interesting question, guys. This is for everyone. So the weekly tasks that you work in your lab, you are submitting in eFolio is an assessment. So I'll give you how it is. So you see here, so you have FIT 5042. So you have weekly task in your lab. So those weekly tasks is just 10%. All right. And then you have assignment practical that you submit, that is 40%. And then you have an e-assessment, that is another 50%. Another 50%. So this assignment practical work consists of, yes, so this e-assessment is a final online exam, and this assignment is individual. This practical consists of code plus design plus research report, and another 10% of it is based on folio plus learning summary, something similar to this. All right, so this part is practical. This part is practical. This part is based on theory. So if you are submitting your weekly task in time and updating your e-folio document, then practically you are securing this part, and rest of the assignment you'll be rewarded out of this. And yeah, and the final is a theory exam online. I hope I had made this clear. However, the results will be based on individually you need to achieve 40% in practical and 40% in theory, and overall 50%. That is MONAS guideline. I think there it is there in one of the slides. All right. So portfolio and learning summary 50%, final exam another 50%. All right, so the textbook is shared. The link is shared in the Moodle somewhere. This one by Antonio Goncalves. So you can find this from MONAS online library and download a PDF copy. Let me know if you cannot find. I'll probably I have a copy myself in my desktop. I can drop it here maybe. Can I? Sorry, I cannot attach any file here. I cannot attach any file here, but yes, if you need a copy, just you can download it from the MONAS library. Okay, just look from the MONAS online library. If you cannot, then let Guan know. Will put it on the Moodle. And yeah, so we'll go back here. So this is the beginning of E7. We have Spring frameworks. So Spring frameworks we'll be building using IntelliJ, the boot also using IntelliJ. And for the web server part, we'll be using Tomcat. I think we have that all listed here. We are using Eclipse, JDK 8, E7, and Glassfish server for Eclipse IDE, and we will use Tomcat server for IntelliJ. So what this Glassfish and Tomcat server is just a web server. What job of web server is very simple. You send an HTTP request, it will send you an HTTP response. Simple as that. All right. So everything is an HTTP request and everything is an HTTP response. That's the job of a web server. And ID is just an integrated development kit. All right. This ID environments have built-in. Okay, these ID environments have built-in things to make development easier. So 5042 is entirely different from 5032 in respect of technology and environments being used. 5032 is C has .NET side. I think Guan is also tutoring that unit. You might see him. So yes, so web services are RESTful. Every big company that has a lot of data with them, they always have a web services. We do have focused weeks based on developing web services. Don't worry about it. Web services, microservices are the recent terms, are the recent things, and we are totally on top of it in this specific unit. All right. So Nginx is another web service. All right. So you can we have so many other web server. There is Apache, there is Tomcat, there is one group. One is web server, another is application server. One is application server. So we do have a bunch of this doing HTTP request and sending an HTTP response. We are not doing any Nginx stuff here, but yes, it's as simple as yum install HTTPD or yum install Nginx. We'll see when we go into higher labs. All right, this is your workload. There is weekly exercises and a practical assignment. I think I had made this clear. You need additional hours, focused hour for this unit. Maybe you need to spend at least 6 hours extra for your lab, guys. All right. If you're not spending time for your lab, I feel this unit might disappoint you. So there are materials available on lecture, tutorial specifications, and exercise solutions will be available to you on Friday. If you haven't completed your stuff by Friday night, the solutions will be available, and you can use the solution, but at least make sure you change the name of the author and everything. All right, at least don't show up the same thing in the code. Make sure in your eFolios you provide screenshot of working code along with the GitHub URLs. I was talking about GitHub, right? So this is GitLab. This is GitLab that Elliot has created. Make sure you create a repository public, because you are sharing it with your tutor. If you don't have your repository public, your tutor will not be able to assess you. Similarly, I have a few GitHub thing as well. So these are different thing, but I'll tell you, they're all essentially implementing the same framework that was developed by Linus Torvald. All right, so they all uses Git to interact with the kernels. So it's good to have repositories created in GitHub. The reason is, when you're going for interviews tomorrow and you have a Git profile, it's definitely giving you an edge. That means he knows how you work with the source control. He knows how you work with the code and other stuff. I think I don't want to repeat this again and again, emphasize on this. Please understand, you should know how to work with Git. Just Google 1 hour quick guide to GitHub. All right. That's the first thing before you enter any coding units. I know a few years back this was not so essential, but I need to emphasize this. Just first is learn how to use Git. So there is something like Code Academy. So from Code Academy, learn GitHub. It's free. All right. There are 100 places where you can learn GitHub. But if you don't understand or learn how to use it, it's very simple thing actually. If you're not able to use it, see, this is just under 10 minutes. It won't take even 10 hours. All right. It should be less than 5 hours. You should be able to complete everything. Understand the branch, understand how team works in Git. It's very simple. So that one thing, and then materials and submissions, tutorial submissions in eFolio. Your respective tutors will cover that. Attendance. So attendance is not compulsory. It is, however, recorded and monitored. So when you log into the lecture, we do get a report who has logged in at what time and is logged out at what time and how much time he has spent on this specific lecture. So we do get proper information about it, about your who is attending, who is not. So this is a very important slide. If you are behind 2 weeks in this unit, I think only God can help you. For this unit, be diligent and try not to uh, fall behind even by 1 week. All right. There is so much heavy task. You need to spend a lot of time. Better keep on going. All right. So you need to understand how to debug a code. Most editors, they have a debugging. You need to know how to debug. Otherwise, you cannot do system.print.io, printx, printy, and run the program 100 times. No, you cannot do that. You need to know how to debug, how to use breakpoints, how to use debugging. You should know. Assessment, we had a discussion. So assignment overview. So we had a brief discussion on it already. This is an overview. So out of this weekly task lab, there are 8 exercises. 8 exercises and weekly submissions to eFolio. And it should be ready by Monday. You look, there is something, a very trick involved here. Even though the solutions are provided to you by Friday, your code should be ready by Monday, because each tutor will go and check your code and how it is working. If it is not working, then it is a big problem. All right. You will be suffering in this 10% of the code, this 10% if it is not working. Solutions will be provided to you and you need to work really hard. So you use your time on Saturdays and Sundays, make sure it works and upload to GitHub, put it in the eFolio, share it to your tutor. Cool. So that's the second part. This is the final exam. This is the hurdle requirement. That's Mona's hurdle requirement. extensions and everything, you can talk to Gwen if you need any. So Monas has strict plagiarism policy. Make sure you don't copy anything, all right? All right, so we are on our slides to start with the course content. I will give you a 10-minute break, okay? It's 6:56. You guys can come back by 7:10. I will see you at 7, 8 or 9. All right, cool. welcome from the break. Some of your friend has asked good question. Some of your friend have asked good question. One is, all the stuff will be taught in tutorial. Yes, we will try to cover as much as possible in the tutorial with explanation. If your tutor cannot, then make sure you follow the labs and check with him with your progress. Make sure everything goes into Git before you before Monday. If you're not doing that, you're actually risking on that 10%. Yes, so you have time till Monday to submit your lab. Till Monday means it's before Monday, all right? End of Sunday or before start of business Monday. Okay, you don't have to download Java EE. There is nothing like Java EE7. Java EE is Enterprise Edition. Using Java Enterprise Edition is the 3-tier architecture that we will cover in today's lecture. Noodles, all right. Model. I hope I have answered that. Will we be brief before assignment work starts, or should we start work on it immediately? So I think Guan will notify you. In your Moodle, there is a place called assessments. So once Guan uploads stuff, for me it is visible, but once he uploads the use case document, it will be available to you, and you can carry on from there and start your design report. All right, any other extra questions? You can check with Guan. All right, you can email it to him or ask him post this lecture. We'll continue with the today's lecture. So this question, what is 3-tier architecture normally consists of? What do you think, guys? Which one is the answer? Okay, we definitely know. So there is a lot of competition going on between C, D, and E. So C is the option with data tier, information tier, and application tier. D is web tier, application tier, and database tier. We'll see what's the, I'll not provide you the answer now. We will get the answer during the course of the lecture. So what is an advantage of MVC approach? So you are doing a web unit. Most of the web frameworks are based on MVC. MVC stands for Model View Controller. So model is an entity class or something which is a real world representation. View is something that model shows up as the view logic, and controller is one which drives the program. Yeah, most of you got it right here though. Separates elements related to user interface view, business logic, and controller presentation. That's the right answer. And for the left hand side, actually, this is the right answer. Number D. You have an application tier. The application can consist of a web app, a browser, or even an app client. Then you have web tier, where you have implemented your web logic and business logic. And then at the end, you have a database tier. This is the 3-tier architecture normally consists of. Cool. Let's get back to our slides. So what's an enterprise software? So it's there in the slide. Enterprise applications are those which are used an enterprise-wide as an organization of organizational level. That's an enterprise application. Basically, enterprise applications have things like scalability. They should be scalable. They should be maintainable. Uh, they should have elasticity with them. They should be able to increase payload, work on increased payload, and likewise. They should be consistent, they should be durable, and information should be uh, persistent and 100% reliable. Um, the reason why I haven't taken Facebook and those apps as an enterprise system, well, for Facebook can be an enterprise, but generally an enterprise system consists of a web app, uh, a web server where business logic is implemented, and a database where all persistence logic is created. Here you have some of the examples. I don't need to tell you what was the answer for the question that I displayed you in the beginning. So enterprise software relates to all such software involved in supporting an enterprise-wide or an organizational level business activities, such as payroll management system and attendance system, likewise. So often web app architecture is distributed. The individual systems are often linked together via web services. This is modern architecture. And there is another approach to enterprise architecture that is called as tiered architecture. Initially, when people wanted to scale things, they came with master and slave architecture, but different areas, different application, they use different approach. So for enterprise architecture, there is a tiered approach. So the tiered approach is separating the presentation logic from the business logic, and separating the business logic from the data persistence logic. Java, I need not say this is a language. Java is platform independent, but the JVM, which implements Java, is not platform independent. All right, one more thing I need to add. For this specific course, if you are using MacBooks, it's well and good. If you are using Windows, I strongly suggest install CentOS or some Fedora or Debian Linux in the VirtualBox. And for this specific unit, use that operating system. I strongly suggest using an operating system with a Linux kernel for programming with Java. Okay. JVM is machine dependent. Java is not. So standard edition is SE, enterprise edition is E, ME is micro edition. In Mac or Linux environment, or even in your Windows, if you want to see where your Java is installed and what version of Java is present, you can simply write Java, open up your prompt or terminal command prompt and say write a version. it will tell you which version of Java is installed, and if you want to know where it is installed, just run userlib executive Java home. It will tell you the path in which JVM is installed. All right. Okay. This. Cool. So API is a collection of software components that can be used to build other applications. It stands for, who can say what does API stands for? So you'll be coming across this term API everywhere. Very good guys, is application programming interface. So API is that interface that abstracts the underlying implementation logic from you. It just gives you a open method or interface that you can use to carry out a specific task. All right, I'll be little quick. I got 30 minutes. So this is SCE enterprise software. Software that is built to support business activities in an environment. So this enterprise software, tire-based architecture. This is important. Multi-tire architecture, often referred as N-tire architecture. Initially, there was client-server architecture. It aims to provide a scalable, flexible, maintainable, reusable model, because you can, if load on a specific system increases, you can specifically scale that. It segregates a system into different tires based on responsibilities of the component, and components are often located in different machines. So if the load on the web is higher, just scale up um, the web machine. So if you have heard about mainframe, it's an example of single tier architecture. Single tier architecture are the ones where both the program and the data lies in the same system, and that is accessed using a terminal. So mainframe is one example. IBM has tons of mainframe into insurance and banking systems. Data lying there since 1980s. So its advantage is that it's simpler to develop application. There is less network and other overheads, and it's quite fast because the response time and the for the request and response doesn't need a network to transfer, so it's quite fast. However, the disadvantages is it's too much monolithic. It doesn't support heterogeneous environments. It doesn't support load balancing. It doesn't support distributed resources. You cannot scale things. You have to add an extra system, add an extra rack and things like that. So it is very monolithic. Program code, everything at one place. So it needs a lot of maintenance. So to come across it, they designed something like client and server. I think you would have heard about it in your bachelor's or things like that. So the client server is a two-tier architecture approach where the business and the presentation logic is mixed together in the fat client, and the data resides in a database server. So database server only data, whereas the presentation logic and the business logic is in the fat client. So the advantage is that it is simpler to develop the business logic, and it is constrained to a single non-distributed system, whereas data can be shared across multiple systems. Whereas disadvantage is it is very expensive to change. I think there are like 5 different clients, and I need to update a software in the business logic here. I need to update it here, here, here in 5 different clients, which is a bit uh, expensive and time consuming, and the scalability is limited. The minimal logic sharing, because application logic is coupled with the client. It doesn't support heterogeneous environment, and there is a lot of tight coupling here. Tight coupling with respect to presentation logic and business logic. So any good software or application architecture would be resilient if it is lightly coupled. It should not be tightly coupled. It should be loosely coupled. That means there is no big dependency among each other. All right, that is called loosely coupled. So out of these disadvantages, they came up with something called as presentation logic to be separated from the business logic, and database logic to be kept different. This is 3-tier architecture. Client logic consists of the presentation, that is your web interface, your scripting, whatever. And middle tier consists of the business logic, like um, if I have to calculate interest, the logic of computing that interest, or logic of validating and other things, that has to be uh, done at business level. The business rules are basically the business logic. And once everything is validated and you need a persistent storage, you store it in a database layer. This is very basic to understand how things will be developed at what areas. So there's a lot of advantage here. It is easy to change or replace any tire without influencing the other tire. Suppose there is an improvement in new client logic. There's a new framework came in where I can have multiple features in my client. I can change my client. I don't have to change my database. I don't have to change my logic. So this is the kind of code reusability, scalability, load balancing. Like there is a lot of load coming in on the database server, let's say. There's high load on database. So you can basically have scaling of your database, horizontal scaling, vertical scaling, all these things you can do. And then there is security policies can be enforced, and then it provides better recovery, as redundant servers can be used to recover systems. So there is something called as backup and disaster recovery. So you need to take snapshots, you need to take backups and all. Those things can be done. How they are connected to each other. So how do you think this your system is connected to Mona's network? It is through the network. They share the same network. Do I answer that? Cool. So one disadvantage is there is difficulty to develop, as consideration needs to be made for multi-threading applications. Sometimes there could be security breaches, but recently the technologies are even much better than this. The architecture is even better than this. We'll slowly progress into when we slowly progress into web services part, the restful stuff, you'll understand what I'm talking about. So this is an example of a coffee shop. So if you I own a shop in Coffville. I don't have any branches. I give credit to my customers and maintain their accounts in a software on my computer. How should my software behave when a customer comes in? So I can have a monolithic, a single tier architecture, uh, something like this. I can have a presentation, business, and database all in one system, and I can I can use it when the customer presents me with a card, ID, or something. However, the situation will change a little if I have multiple multiple centers, like one at Caulfield, one at Clayton. In that case, I need to have a separate web client or some app client that is just an interface. And then somewhere in a data center, the business logic and database can be implemented. Think about I have uh, coffee shops running in Caulfield, Clayton, multiple other places in Melbourne, Sydney, and all over the world. I cannot go with this architecture. I need to have a 3-tier architecture where the presentation logic is separated from business logic, because maybe in Australia the business has similar government regulations like 5% tax or 7% tax, but if I go to Singapore it will have a different tax system. So everywhere the business logic will be different. So if you're maintaining an enterprise software organized and wide that runs across multiple geographies or multiple business areas, you better keep your business logic separate from the presentation logic. And to store or persist your data, use database server. Java EE platform. So Java EE platform uses distributed multi-threaded architecture, multi-tier architecture. The components are a client tier and a web tier, business tier, and EIS enterprise software. So client tier runs on the client machine. It can be a Java applet or a Java Swing application. I think you guys have heard about applet and Java Swing. So those are a part of client tier, and web browser, which interacts with the web tier, is also in the client tier. So browsers, applets, Java Swing, app clients, they're all client tier. Java JSF based XHTML pages, JSP pages, Java server components, web XMLs, they are all web tier. And business tier consists of EJBs, which stands for Enterprise Java Beans. And then comprising everything is your Enterprise Information System tier, that is EIS tier. So it consists of different components. These components are self-contained and they can communicate with other components. So each component consists of classes and files. So Java specification defines these components. One is app clients, JSPs, JSFs, and these things. They're all clients, all right? They're all client, your browser related stuff. Then you have EJBs. Very important. Understand EJBs will implement your business components that run on your e-server. So this is the diagram that you have to remember. So your JSF pages or JSP pages are part of the web project. So these JSP or JSF based pages, they are interpreted or converted by a servlet engine to render an HTML page in the client tier. So when you create web applications in Java or web applications in any framework, so there is a core engine that converts the code that you write into HTML pages. And it's a job of the web server to respond to a request with an HTML output in HTTP protocol, that is an HTTP response, an HTML output. So HTTP is hypertext transfer protocol, HTML is hypertext markup language, and JSF is based on XHTML, extended HTML. So XHTML is interpreted by servlet engine, which interprets and renders you that HTML output. So HTML output that you see on your screen or in your laptop or any client is actually client tier. Whereas the remote server where your Glassface is running or a Tomcat is running, where your web project is deployed, that is web tier. Even your business logic is also deployed to your web, because a business logic doesn't reside on the client side, it always reside on the server side. And then whatever business decides, so this is DAO layer, database access object layer. Once it decides the objects to persist, it can persist to a database. So this is persistence layer.
Sunil, I had a question.
Yes, please.
I wanted to ask for a specific term like for search engine optimization, which uses business logic as well. In which layer do we implement that?
So search engine optimization, SEO, is not an enterprise web application. It is a different application, but it is not a enterprise web application. And definitely it has its own business logic somewhere. There are something called as robots which is running. There are other principles which is running, which is alien to this course. It's not related to this course, Tarun.
All right, thank you. Yeah.
All right.
Yeah.
So if you ask me how Google is running the search engine search, what are yellow pages, how tags are maintained, how metadata are maintained by Google, how Google uses robot to run searches, to do use a lot of learning algorithms, use your cache, use your web history and all. There is not the scope for this unit. I'm sorry. For that, there are a lot of things that is non-technical in this SEO part, and there's a lot of things which is technical in SEO part. However, here we are building enterprise web applications. A system such as you log into Commonwealth Bank or a National Australia Bank, and you see things which is very responsive, and you see things which is always available to you. You see things which is very consistent in his behavior. Those are enterprise applications.
Yeah, understood. Thank you.
All right, cool. And the applications that we are going to code or prepare will follow this multi-tiered application. So they have three tiers. One is the client, one is the web tier, another is database tier, app tier, web tier, and database tier.
So
All right.
I have a question.
Yes, please.
So on the client tier, the client is running this application in the web browser, right?
So client is running the application. You are talking about application client or just the web pages?
The web pages and the
Okay.
application client. Like, I'm confused. Where is the application actually running? Is it running in the web tier or in the client tier?
So Application is actually running in the Java EE server. Okay.
Yeah.
Uh, when I say application as in there are different components to that application. Application part uh, actually is just a request response rendering stuff, which is an HTML page. So this is what you see as an application is actually a web application, right? So for web application, how do you interact? You interact through a web page, isn't it?
Yeah.
So basically what you see here as an application, a web application is an HTML page.
Okay. So like this HTML page code, is this running in the web, in the Java EE server?
All right. So this HTML code that you are seeing in your web page is actually sent by the web server.
Okay.
Sent by this web server. When you requested for open that page, the web server sent you that page.
Okay.
All right. Uh, and the response was an HTML page. But when you coded that page and deployed it to the web server, you actually coded using Java and Java related technologies, deployed it, and it was interpreted by a servlet engine and then rendered you with an HTTP response, which is an HTML output that you see on your screen.
So the client here is purely front end based, right? Like client
Exactly.
is looking at a HTML page, pressing a button, and like doing their stuff in
Correct.
the client tier, and then
Correct.
making a request on the web server web tier, and the web tier is responding accordingly.
Correct.
Okay, understood.
So the application that you see is a web application. That means whatever you're seeing is you are interacting in a web browser. And that browser is actually rendering content that has been responded by the web tier. And that response is done by a core servlet engine, which is implemented by servers like Glassface or Apache, Tomcat, and all these things.
Yeah.
Okay, those are all web servers. And all these web servers, they do a simple thing. They just do an HTTP response for an HTTP request. But there is something inside this web tier. When you will advance into consecutive weeks, we'll look at the content. The things that you develop is actually a JSP page or a JSF page, which is deployed here. And that is frame. When you go to the life cycle of JSF or JSP pages, you'll understand that they are interpreted and they are prepared into an HTML output in the web server before sent to the client. All right.
Yeah,
Cool.
thank you. Understood.
Cool. So when we go ahead, you have clients. There's a web clients. Web clients usually consist of two parts: dynamic web pages. So everything that you do is you interact in a web browser, which renders the page that you received from the server. So the web client does not usually access database directly and execute complex business rules or anything. And the heavyweight operations are offloaded to EJBs. So this web server, they also run EJBs, which does the business logic. So they directly do not, these browsers, they directly do not put things into database. When they display you something that is reflected from this JSF pages. And what is reflected here is based on the heavy lifting or business logic that has been done in the EJBs. And these EJBs, they act as a DAO, database access object layer, the DAO layer, which access the database, manipulate things, do business validations, and then provide the response to the web server, which then renders the HTTP response. Okay.
So I have one more question, Sunil. So the EJBs, they're basically hard coding the queries that will be made into the database for requesting data or um, putting in data into the database, right?
As of now, for your understanding, yes, they will be having the queries. They will be having the schemas that relate to the uh, tables in your database. But what you hard code and what you make it flexible, it depends as in up to the developer's choice.
Okay.
And if you want to see how they are done and everything, probably you would have got a idea based on the task 2 of your lab 1. And it uses an EJB for calculation, interest calculation. The logic for interest calculation is might be incorrect there. So based on what you write in EJB is how business logic is implemented. For your task 2 in your lab, there is no database access involved, but is definitely uh, a web browser here talking to a Glassfish server, JSF page, and getting a response back here. All right.
Right.
So you see a page here is a reflection of the from the Glassfish server, which uses the monthly calculator bean to compute the values that you passed in your web page to compute the interest. If it want to interact with the database, it will interact. But if there is no requirement, it will pass the values back to the JSF page. JSF page will be interpreted by the servlet engine and then rendered back into your output web browser. So I hope this gave you a good understanding about multi-tiered application, different components of it, and what is a client does, what does browser does, what's a web client is, and all. Cool. So, so these app clients are also part of the clients. They are generally GUI based, developed using Java Swing or Applet. Uh, we are not encouraging much development of the app client in this unit. But yeah, if you are interested, you can go ahead and start creating an app client based on Java Swing. We used to have, we don't have it now. Same as the applet. Applet is the old version of Java Swing. Uh, then we have web components. Web components are either servlet or web pages created using JSF technology or JSP technology. Servlet are Java programming language classes that dynamically process requests and construct responses. So this how these frameworks around Java has evolved is first there was Java, and then there was lot of uh, networking things came up. So they came up with a thing called servlet as a technology. What servlet did was a very simple thing. So it have Java and HTML embedded into it. So when you run a servlet, it produces if you run that servlet Java class, it will produce an HTML output. So uh, they then saw there is a bit of difficulty in creating flexible web pages using servlet. So what they did was they created something called as JSP, Java Server Pages. So JSP uses HTML and then it embeds Java into it. And then ultimately, the framework then creates a super class from the JSP page and then pass it to the servlet engine, and then the servlet engine gives that HTML output. So servlet is basically the core of Java-based framework engines. So servlet is the Java programming language that dynamically processes requests and constructs HTML responses. JSP pages are text-based documents that execute as servlets. The things that I just told you in a more natural is just that evolvement of Java to HTML side by servlet, and then her servlet became bit limiting. So they started using JSP, where they embedded Java into HTML and passed into servlet to produce that HTML output. And JSF, Java Server Faces, is built on servlet and JSP to provide an UI that can work seamlessly with different web applications. Okay. All right. So we have Java beans. The beans, when I call anything as beans, by default, I refer to an entity class, or by default, I refer to a Pojo class. Pojo stands for plain old Java object. So Pojo means it has set of attributes, getters and setters, and constructors. So the attributes are private, and by default they can be accessed only via getters and setters. Getters and setters are also known as accessors and mutators. So if you have private attributes of a class, public or protected getters and setters with a default constructor, it is a Java bean class. They're often used to manage data flow between clients, components, and they run on the Java server, server components, and database. We will see how we can create entity classes that can map via object relation mapping to database tables. That's a bit further down the line in week 4. But yeah, I'm just giving you an idea right now. And then you have business component. Those are EJBs. You write, implement all the business logic in EJBs. EJB is definitely server side. So if you're creating just a Java project, it's Java perspective. If you're creating a web project or an EJB project, it is definitely enterprise Java EE, and that has to run on a web server. All right. Database is independent. You can or cannot have a database. If you want persistent storage, you need a database. But if you're running anything on EJBs or you're running anything on the web, it has to run on a web server, such as Glassfish or anything. So there are two kinds of EJB, the session beans and message-driven beans. Session beans perform a task for a client. It may implement a web service. Message-driven bean act as a listener for a particular messaging type, such as JMS, Java Messaging Service API. Uh, for this particular unit, our entire focus will be only on session beans and different types of session beans. So there are two types of EJBs, session bin and message driven bins. We'll be focusing on the session bin. So EIS tire is comprises of the whole, and these are the examples: mainframe transit system, database system, enterprise resource planning system. This Java EE containers. So there are containers running in Java server. So inside server, there is a web container. So inside the server, there is a web container. This is server container. And then there is just a servlet engine or a web partial server container, a HTTP application server. And then you have an EJB container. So there are 3 different containers here: a whole web server that comprises of HTTP, HTTP response, request response web container, and the one consists of the business thing, the EJB container. So the EJBs will lie inside EJB. We'll see in detail in the coming classes, but yeah, that's an whole idea. I gave it to you. So those are all described here. You can have a look. And then you have assemblies. Assembly is once you create the project, you need to first write the code, then build the code. Building the code will create related packages, and then publish it. Means it is deployed to different environment. So there are basically 3. So there is one EJB container, web container, and then don't focus about this part, these 2 part. Just focus about these 2. One is server container, and inside the server container we have web container and EJB container. So anything that is deployed into web is web archive, WAR. Anything that is deployed into EJB or enterprise is EAR, which is enterprise archive. So these all archives are basically Java executables. Just like in Windows, you have seen .exe as an executable, as in Linux or in Mac, you have seen .dmg as an executable. Similarly, in JVM environment, if anything that is jar file is Java executable. It contains all the class and libraries. Web archives are web executables. It contains Java modules, HTML, XMLs, and deployment descriptors. EAR is enterprise archive, packaging enterprise applications that contain jars, wars, and other EARs. So EAR is a top, which can be contained in another EAR. So that's the summary we had for today. If you have any questions, you can shoot to me. There are 2 things to prime takeaway from this class. One is the architecture and different executable types, jar, var, R, and different containers, EJB container, web container, and the server container. And yeah, and the multi-tiered stuff. So yeah, this is the main takeaway for this thing, for this class. I plan to actually show you a demo for the week lab, but I don't think I have time. Probably your tutor, respective tutors will help you with that. Any other questions before we stop the meeting? Cool. Thank you, everyone. Thank you, guys.
Thank you. See you next time.